mental health day tomorrow? Yeah. We should just like all skip. And that would be our mental health day.
All right, so what we're gonna do is, can you see that? Oh no. Okay. So what we're gonna do is we're gonna talk about our questions. This is one of the question I didn't put on the test, which is will be on the next test, which is I'm glad you didn't put on the test because it seems like a lot of people didn't know how to do. But that's 1 minus t squared dt. So obviously that you cannot take integration of this with the u substitution because if you u equal to 1 minus t squared, the du is negative 2t. But negative 2t is not within the question, so there is no way to substitute that. So therefore, it's not possible to take integrate or something now. You can take integrate when you go to calculus 2. You have to do something called partial fraction. They actually just learned this on BC Calc. So you have the decomposition of that that expression into integrable situations. So, but in this case, we don't have to integrate because we just have to assume that f of t is equal to 1 minus t squared. So I'm going to take a d to the dx of sine of x of pi, and that is going to be f of t dt. Are we okay? D to the dx, if I integrate this, that's going to give you big F of pi minus big F of sine of x. And then now you just did fundamental theorem of calculus. And now after that, you're going to take a derivative. If I take a derivative, it's going to become small f of pi. And remember, anytime you have a constant, if you take a derivative, that's going to be a 0 due to chain rule because you had to take a derivative outside and inside. And then you're going to go back, and you're going to say minus f of sine of x times cosine of x. Good. And that's equal to 0 minus, now this is a f of x here. We had to go back. So we're going to plug this into here. So it'll be 1 over 1 minus sine square of x times cosine of x. So we know that it's going to be negative 1 over cosine square of x due to Pythagorean theorem identity. So that's equal to cosine of x. That's equal to negative 1 over cosine of x because 1 of the cosine of x is going to cancel out. And that's actually end up to be a secant of x, negative. So that is my final answer here. And that's one of the questions. I did not test you, but it's here. Yes.
On the FRQ part, if we don't write like assume like ft equals like 1 over 2.
This question will not be on FRQ.
Oh, okay.
It'll be on the multiple choice.
Okay.
Yeah, I can tell you which questions on which one, like 100%, but this is not a FRQ question. There's a competition question still, so if you join the competition, then this will be a competition questions. And it's also on AP exam. So. Any questions here before I go in further? Okay. So now we're going to talk about motions. What is a motion? This is a motion. Motion, it has a positions. So basically talk about physics, velocity, and acceleration. And you pretty much just going to learn how to utilize the formulas and think about all those things. So first of all, let's talk about the notations. It's going to be S of t. I usually say that's the positions. Now, some of the AP exam question, they do use x of t. X represents a particle traveling x directions, which is horizontal directions. So they can also call it x of t. So, so if I take a derivative of this, what am I going to get? If I derivative of position, what am I going to get? Velocity. Good. We learned that in physics. right? Or x prime of t. So either way, it's fine because it's just different notation. So that's also, the new notation is going to be v of t. We talk about that. So there's a position, velocity, and the acceleration. So it's going to be a s double prime of t, right? So that's equal to acceleration. Or is equal to x prime of x double prime of t. So sometimes it can be like that, or sometimes it can be v prime of t. Because if you take a derivative velocity or you take a double derivative position, they're exactly the same thing. And finally, we know that's equal to a of t. If I take a derivative, you got. So usually it's a PVA. If I take a derivative, it's going to go this way. But now we're going to talk about, can we take integrations? If I take integration, it's going to go this way. So this is an integration or antiderivative. They are the same meaning. And this is the derivative. Okay, this is the derivative. Okay. So, are we okay here between position, velocity, acceleration? Three things. Now, if I start by understand what's a velocity first, there are two type of velocity. Do you guys remember there was a two type of velocity here? So there are two type. First type is what?
Instant.
Average and instant. Good job. You guys are awesome. So average. Now I'm going to start with the instant. How to spell instantaneous? E-O-U-S, U-O-U-S, E. E-O-U-S? That doesn't sound right.
What's T-A-N?
Instantane. E-O-U-S. Instantaneous velocity. Imagine Mr. Ye join spelling bee. I won't make it to pre-round. Spell your name. I don't know. Instantaneous velocity and the average velocity. So instantaneous velocity is just take s prime of t, right? Or we call it v of t, right? If I take a derivative, it's going to be instantaneous velocity. Now, what's average velocity? It's changing of positions, right? Guys, you have to know this, changing position over changing time. Now, remember I asked you the average rate of change? This is sound like it, right? So it's basically average rate of change of a position functions. So a lot of people thought is v of b over is s of b minus s of a over v over b minus a. Does this make sense? Because s of b minus s of a, which is final position, minus initial position, that is going to be the difference of position over the difference of time. Is that confusing? It's okay? Okay.
For average velocity, you need two different times.
Yes, you do, because you are basically talk about if I run from here to you, let's just say if our distance is like 20 feet and it takes me 3 seconds to get there, so it'll be 20 feet over 3 seconds. That's my average velocity because that's my changing position over changing time. So it has a time difference between here and there. So it takes me 3 seconds to get there. Does that make sense? Okay. So Now, the problem is people always confuse is average velocity. They thought is this. So please do not do this because they say average velocity must be the changing of velocity over change of time. This is wrong, right? This is wrong. Please don't do this because this is not correct. This is actually end up to be something else. We're going to talk about it in a second. But they are not changing of, it's changing of distance over changing time. So that's wrong. So now turns out there's a second way to talk about this. Remember we talked about average rate of change and the average value, right? What if today I give you a velocity equation and ask you to find the average velocity? I don't have a position equation. I only have a velocity equation. What do you do? What'd you say?
Can't you just take the integral and then plug it into the equation?
Yeah, but if I integral, then I will get a changing of positions. You're almost there. You learned this. If I give you a velocity, so what's the question? If I give you a velocity equation, can you find me the average velocity between two separate times? Yes? Almost. Almost. Yes. What? Exactly. Integration of v of t dt, because I need to go into positions in order to find average velocity, right? So then I have to integral v of t between a to b and 1 over b minus a, which is, remember, this is an average value. And it was supposed to be on the last test, but I didn't. This is an average velocity. This is average velocity, but it turns out it's an average value of the velocity functions. That's also same thing as the new things that you don't know about average velocity. So the average velocity is equal to this. Got it? Does that make sense? Why? I'm going to explain to you. If I integral v of t, what am I going to get? S of t, right? So it's going to be S of b minus S of a, right? Does that make sense? And this is going to be times 1 over b minus a. Does that look like the same thing as this? Wow. Something pretty cool, right? Something pretty interesting. You got it? So today you're gonna have a worksheet that you're gonna have to figure out how to use those formulas using the information given to you and figure out what to do. Is that okay? Now, what is average acceleration? Average acceleration. It turns out it just v of b minus v of a, because it's changing velocity over changing time, which is you finding a slope of velocity. So therefore is average acceleration is equal to this. But some people get confused. They thought this is average velocity is equal to this. No, this is actually average acceleration. So please look at the right thing. Now, also we're going to talk about what if I have integration of s of t or x of t So remember, this can be x of t. So I'm sorry, that was bad. Integration of a of t is equal to what? What's the integration of a of t? V of t. But you're gonna have to pay attention. There was a plus c. Usually that c means the initial velocity. And integration v of t dt is equal to s of t plus c, or x of t. Remember, they could be the same thing, because I use s. Sometimes AP is going to use x of t, because x of t represents a particle traveling x direction, which is the horizontal direction. If you run from end of hallway to here, then that is the changing of x. If you run, I don't know, you can run vertically, but then there's going to be changing y if you can do that. Or jump vertically, right? Then that's going to be y of t. So it really depends on what it's saying. Am I confused you in any moment here? Okay. Those of you guys take physics, you should know what's the difference between speed and velocity. Can you tell me what's the difference between speed and velocity in terms of math? How would you describe? If somebody asks you what's the difference between speed and velocity, how would you say? Yes, Sarah Jung.
Like speed, it's a scalar quantity, so you can't have the direction, so it can't be negative. With velocity, it can be negative or positive because it has a direction.
Right. Right. So like just say, and you have to assign a direction also. So that's a velocity usually you assign, says going north is positive, going south is negative, or going right is positive, going left is negative. Once that's assigned first, then you can say, I'm going to New York, driving 100 miles per hour. Then that's positive 100 miles per hour. If I'm going to Miami, if we're going south, because we assign north is positive, south is going to be negative 100 miles per hour. And you're going to be like, you driving negative 100 miles per hour? Can you drive backward? No, you're just driving a different direction as opposed to assigned directions. Right? Does this make sense? Now, speed doesn't matter where do you drive. Right? It doesn't matter if you drive in north or south or west or east. It just, that's 100 miles per hour. It didn't matter. So the speed is equal to absolute value sign of v of t. Because I don't care about what positive, negative. I just care about positive. That's the only thing I care. I don't care about anything else. Then you say, oh, okay, that kind of makes sense. And so that's speed. Now let's talk about the next thing is, so sometimes I'll ask speed, then just take absolute value velocity. What's the next thing you have to pay attention to? Next thing is you have to pay attention to total. There were two types of total. So there was total displacement versus total distance. Now, which one do they test more often? It's actually total distance, but they can test you total displacement as well. If I give you a velocity equation, how do I find the total displacement? If velocity is given, how do I find the total displacement? So if velocity is given, how do I find the total displacement?
Multiply by time.
No. Yes, Gage?
Displacement position when you take integral.
You take an integral, right? You take an integral of v of t, right? Between a and b, right? That's equal to s of b minus s of a. Does this make sense? If you integral velocity, I'm going to get position. Position, if final position subtract initial position, that's going to give me a total displacement, and that's the change. Now, sometimes people get confused between total displacement and total distance. what do you think the difference between total distance and total displacement? Yes.
Isn't displacement like you're moving from like a certain spot, whereas like distance would just be like how far you went in general? But like if you walk in a circle, your displacement would be 0, but your distance would be like the way around.
Pi r squared?
Yeah.
Okay. So yeah, you're absolutely right. So I'm gonna create a situation. This is Mr. Ye. Right in here. This is me. In 1 second, I'm gonna go 1 step. And then I'm gonna go second, I'm gonna go 2 steps. Oh, actually, let's just go with easy. I'm gonna go 1 step forward and 1 step back. In 2 seconds, what's my total displacement? 0, because I'm going around circles. I'm just like he says, if I'm going around circle, there's no displacement at all. But if I ask you total distance, what's my total distance? 2. So we can get integration to this, right? But what is total this distance in terms of the equations going to form? What is it? What?
Would you add some subtracting? I don't know how you do that.
No.
Would it just be S3 minus SA?
Nope. I know what you're talking about, oh, Katie. It can actually work if you understand a little bit more.
Can you do like SB plus SA, but I don't know how you like write down like the integral part of it, so.
So with that 1 step forward, 1 step back positions, I will show you the velocity graph will look like this. The velocity graph is going to be like this, and that's going to be 1 unit, and it's going to be like here. Sorry. So this is 2. So 1, 2. Now what happened? If I do this, right, and this, if I do total displacement, what happened? Positive area and negative area, what? Cancel out, right? So that's equal to 0. Now, how do I find total distance?
Yeah.
There you go. Why? Because if the absolute value of velocity, what happened to this line? It becomes a positive, right? So then it becomes 2. Any part negative graph, remember on the last test, I test you something like this and something, I don't know, something like this, right? Something like this. And I say, hey, this is f of x, and I want an integration of absolute value f of x. What does that graph do? Go like this, right? So you find an area here and you find an area here. Do you guys remember that? Same idea. I'm just making this negative become positive, then therefore I got 2. Math, right? Pretty cool. Is this confusing at all? If it's confusing, please let me know. I think I can be a pretty decent physics teacher.
So you're just saying like if it asks you for like the total distance and like the problem, it's basically just saying take the absolute value.
Yeah, just the absolute value. I forgot to put an absolute value. You're right. It's gonna be absolute value.
Okay.
So you need an absolute value here.
And then you just do like a normal interval basically,
Mhm.
doing displacement.
Yeah, remember we can using
Yeah.
the triangle to find out the area under the curve.
Yeah.
Good? Yes. Oh, you can do that. You can, it's gonna be absolute value S of B minus S of A. But the problem is, that will be bad. No, I cannot write that. The reason why I cannot write that, right, is you cannot subtract the two positions because that's still gonna give me zero because something else.